question 23, and we're looking how the flux changes as we've got a magnet that's going into a coil. So we start off with a coil, let's say over here. We'll just represent it like this. Here's my coil, and here's my magnet over here. And we start off with it all the way over here. There's pretty much no flux going through it here. Remember, your flux is your lines of field, so they're going to be going around all over the place in that kind of butterfly shape. And what we're going to do is we're going to move that magnet into the coil. So the magnet comes in, and then we're just going to stop it when it gets inside. So as the magnet gets closer and closer, more of those field lines are going to be going through the coil. So the flux through the coil is actually going to increase. Okay, so if you imagine here's my magnet, I've got my field lines around here. The closer I get my magnet to the coil, the more field lines are going to go through that coil. So we're going to have an increasing flux linkage as we move that magnet towards the coil. Now if I leave the magnet in the coil, the field lines are going to stay where they are because the magnet's staying where it is, so the flux is not going to be changing. So we start off with the flux increasing as we move it into the coil, but then when we stop, we're not changing the flux anymore, and therefore the flux is going to remain constant. The magnetic flux linkage increases first of all, and then it becomes constant when we stop that magnet. So your answer for that one increases and then becomes constant. That is going to be 23B.